Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on December 8, 2025, about 5 days ago. It shows that a tiny adapter with just a single attention layer can compress huge vision features into compact latents and still power top-tier image generators, hitting a Frechet inception distance of 1.29 and 1.70 on ImageNet 256 with classifier-free guidance and 1.48 and 2.08 without it. The paper is titled, "One Layer is Enough, Adapting Pre-trained Visual Encoders for Image Generation." And, as we will see later, the implications for reusing pre-trained vision models in generative pipelines are quite significant. Alright, Figure 1 compares 4 design choices for connecting image generators to visual encoders. The left two pipelines rely on pixel encoders that output low-dimensional latents of 432 channels, while a separate representation encoder remains unused by the generator. The third pipeline, FAE, feeds very high-dimensional features with 1,536 channels directly into the generative model, which is powerful but heavy. The rightmost pipeline, FAE, inserts a tiny single attention encoder that compresses those 1,536 dimensional features down to 32 channels, so the generator stays compact while still benefiting from rich semantics. Well, Figure 2 explains how the training actually happens across 3 stages. The left panel, Stage 1A, trains the single attention encoder and feature decoder together so that 32-dimensional latents can reconstruct the frozen representation features. The middle panel, Stage 1B, trains a pixel decoder directly on noisy 1,536-dimensional embeddings, which makes image reconstruction robust to Gaussian perturbations. The right panel, Stage 2, then reuses that pixel decoder and fine-tunes it on reconstructed features while keeping the original representation encoder frozen. Alright, Figure 2 covered how the training pipeline works. Table 2 now shows how that design translates into ImageNet numbers. The highlighted FAE rows achieve Frechet inception distance around 1.5 without classifier-free guidance, and about 1.3 with it, which matches or beats most latent diffusion baselines, despite using the same generator size. The time step shift variant gives the very best scores, so a tiny scheduling tweak further stabilizes training and improves quality. So, the previous table focused on diffusion over ImageNet, while Figure 6 shifts to latent normalizing flows with the StarFlow model. The left panel shows that without classifier-free guidance, the FAE's latents drive the Frechet inception distance down from about 20 to below 7, clearly beating the SD versus AE baseline across all epochs. The right panel reports the guided case, where FAE again converges faster and ends near 3, versus roughly 4.5 for SD versus AE. This gap means the compact FAE latents make training not only cheaper, but also more sample efficient for flow-based generators. Alright, Figure 6 dealt with flows, while Table 4 moves to text-to-image results on the MS-COCO benchmark. The upper rows list famous systems like DAL-E, Imagen, and Re-Imagen, which reach Frechet inception distance around 7 using hundreds of millions or even billions of training images. The shaded FAE rows show Frechet inception distance between about 7.6 and 6.9, yet they train only on the CC 12 million dataset and use roughly 1 billion parameters, so they are far more data efficient. So Table 5 puts the encoder choice under a microscope. The left side lists 4 options and reports linear probing accuracy, where single attention reaches about 86% and matches the Dino versus 2 backbone. The right side shows Frechet inception distance across training epochs with and without classifier-free guidance. Single attention consistently gives the lowest Frechet inception distance, while the linear and 6-layer transformer lag behind, and direct prediction from Dino versus 2 performs dramatically worse. This pattern supports the claim that a tiny, single attention encoder is the sweet spot for both understanding and generation. So the big punchline is that a single attention layer plus a double decoder is enough to turn huge frozen vision features into compact latents that work brilliantly for both diffusion and flow-based generators. This makes reusing self-supervised vision encoders far simpler and more data efficient. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.